Thanks, everybody. Appreciate being here. I love Las Cruces. Have many fond memories of being here, and I've been here at this conference since it started. So thanks, Pat, for being patient with us. Gary Wentz, our Vice President of Human Launch Services, couldn't make it today, so you get yours truly. So, oh, where's the clicker? Here we go. I'm sorry. Okay, so 111 launches. Had it not been for a small fire on the West Coast and hurricanes on the East Coast, it might be more than that today, but that's what it is. So we're very proud of our success history, and we're looking forward to more success in the future. I want to talk a little bit about our vision. Our mission is to save lives and explore the universe, connect the world. These are things that, it's not launch rockets and create fire and smoke. It is something with a purpose for which there's a demand. And our vision is that we want to be able to unleash mankind's potential in space and do that with increased capability, lowered cost, and to be able to enable new missions. And that's on the way to creating a self-sustaining space economy. So wanted to show you a little video. And, oh.
3, we have ignition. 2, 1, 0, and liftoff of the United Launch Alliance rocket for the United States Air Force.
Thank you. The video outlined kind of what I'm going to talk about today. It did say 106. That video was created a couple months ago, so it is not current up to spate, but it shows a broad spectrum of what we do at ULA and what we're doing for the future. So besides the national security payloads and the commercial and NASA science payloads that we launch and that are very near and dear to our hearts, we've also been working very closely with Boeing on the CST-100, the Starliner, human spaceflight capability development. And I helped start that program, worked on it for 5 years, and it's very near and dear to my heart. I want to see it succeed. It is an incredible capability. We've done some amazing things with that. In addition to that, we're also working with Boeing on the interim cryogenic propulsion stage. It's a Delta upper stage that's being converted to fly on SLS as well. And then in addition to that, we have some cargo missions to the ISS, flown a couple of Cygnuses for orbital ATK, and looking forward to working with flying Sierra Nevada's Dream Chaser to the space station to deliver cargo. These are some of the upgrades we've made to Complex 41 as our future infrastructure upgrades. You can see the tower being built there for astronaut ingress and emergency egress. You see the tower going up and the arm being added. and then at the very bottom right there, we're also developing the capability for emergency egress. So it is really transforming the landscape there at the launch site to show, to be able to enable the crew access there. As far as safety enhancements go, we have been working very hard with NASA and with Boeing to demonstrate not only the reliability but the safety of the Atlas Centaur vehicle. So we have 65 launches to date. As Tim mentioned, 71 RD-180s have been flown so far, and that's a lot of data that basically demonstrates the reliability and the robustness of the Atlas V upper stage. In addition to that, we're incorporating an emergency detection system that in case a system fails, the EDS will detect that failure in time for the crew to safely abort using the crew capsule abort system that Boeing is incorporating on the Starliner. So all this data is being thoroughly reviewed and will result in a human spaceflight certification for launch. So we're coming to the ISS shortly. So as part of that continued evolution, we've been a primary launch service provider, as I said, for the U.S. government. We have evolved to be able to allow the next generation of astronauts to fly to the space station safely. And we have a wealth of experience, highest reliability vehicle, and we understand the critical nature of human spaceflight and really what it means to those who are riding on the rocket and their families as well. So what's next? ULA is just not staying stagnant. Even though we have great success, we're evolving to new capabilities. And I want to talk to you a little bit about going beyond where we're at today. This is our 20-year product roadmap, and basically outlines our transition from the Atlas and Delta programs, the current Atlas V and Delta IV programs, to the new Vulcan booster. And right now we are flying the RD-180. We plan to transition off of that by the end of the decade and transition to a new engine, and the booster is specifically being designed around this new engine. And our primary path is the BE-4 engine built by our partner Blue Origin. And that's coming along really nicely. And we're also have an alternate path as a backup just in case with the AR-1, and that's the LOX kerosene engine. And both of those are viable solutions to the Vulcan booster. And we're looking forward to flying that mission, flying that booster in the future. Right now it's slated for an ILC of the end of 19. Once that is online, we are working to, we'll retire the Delta line, and we will, except for the Delta IV Heavy, and we will continue to fly that mission as required until we develop the Advanced Cryogenic Evolved stage. That's the ACES vehicle. It's the upper stage, and I'll talk to you a little bit more about its capabilities here in just a second. Once that ACES is developed, we'll be able to retire that Delta IV Heavy, and then we'll have a single vehicle in our stable that'll fly with up to 6 solids on it and be able to deliver more than Delta IV Heavy performance. And then in the future, we're looking at potentially reuse of the booster engines, but also reuse of the upper stage, which is really a critical capability, we believe, that enables Cislunar 1000. So we want to be able to enable demand, not just. We've had a pretty flat market in the industry, spaceflight industry. I don't know if you remember in the 80s and 90s, we had this rolling wave that showed that we were going to darken the skies with satellites, and the number of launches is going to go way up. And the fact of the matter is that the market has been pretty flat. It's been a little over 100 launches for as long as we can remember. And I think one of the reasons, I haven't ferreted this out through research, but my own supposition is that technology is keeping the launch rate flat. And so the increase in terrestrial technology, the ability to communicate on land, as well as the increase in the capability of satellites that we launch for greater and greater bandwidth, has reduced the requirement to launch greater numbers of satellites. So that demand has remained flat. So we have to look at ways of creating new demand, enabling the capability, creating the capabilities to enable this new demand. I want to talk a little bit about that. I'm going to tell you a little story, since we're telling stories today. Talked about Hawaii this morning and a little bit of Tim's adventures. But I want to talk a little bit about Sacagawea. Sacagawea, I think it is. She was 12 years old when she was kidnapped. She was part of the Shoshone tribe up in Idaho, and she was kidnapped by the Sioux Indians out of North Dakota at 12 years old. About a year later, she was sold to a gentleman, I guess he's a gentleman, a trapper, Quebec trapper by the name of Toussaint Charbonneau. And he was a trapper. He married her at 13, and which I'll just leave the political things out of this. But anyway, he married her, and that's about the time that Lewis and Clark were coming through North Dakota. And as good program managers always do, they always build in extra margin and lots of capability into their programs. And they did just that. They hired Charbonneau to be their trapper. And they also hired him because he was married to Shoshone, who spoke the snake language of the Shoshone tribe. And they took him along with them. Sacagawea was several months pregnant at that point when they started their journey. And they went across, when they got to the Rocky Mountains, they had to haul their canoes up the mountain. And by this time, they're running low on food. They didn't have enough margin in their food banks. And they had these heavy canoes. And their men were hungry and cold and starving. And then they came upon a band of Indians that were ready to kill them. And this band of Indians just happened to speak the Shoshone language. And as it turns out, it was Sacagawea's brother, was the chief of this tribe that they encountered. And so, as it turns out, instead of being eaten and killed by the Indians, I don't know that they were, cannibals, but I made that up. Instead of being killed by these Indians, they were welcomed. This reunion between Sacagawea and her brother, the chief of this Indian tribe, was a bonus for them. This extra capability that they brought along turned out to be very handy for them. In fact, the Indian tribe not only did not kill them, but they traded for their canoes, they gave them horses, they gave them food, and they helped them get across the Rocky Mountains safely. And that is what we call the Northwest Passage. And so because of that, we were able to explore the West and explore new territories. And this extra capability that they brought along turned out to be a bonus. And that's what I want to talk to you about today. You're like, how does this story tie into space? I'll tell you. ACES, our Advanced Cryogenic Evolved stage, is our next generation upper stage. It's built very similar to the Centaur, except that it's greater than 3 times the capacity. And it is made out of the stainless steel monocoque construction. It's got a common bulkhead, carries 150,000 pounds of propellant, hydrogen and oxygen. It is a leap forward in new technology, and I'll explain that in a minute. In addition to that, we're looking at cutting the cost of this dramatically, such that a Vulcan ACES would launch in its configuration performance of a 541 for less than the cost of a 401, or a Delta IV Heavy for less than the cost of a 521, and then be able to launch crew without SRBs. Pretty dramatic change in our capability and our affordability. In addition to that, we'll be able to have 20% more capability than the current Delta IV Heavy and increased mission flexibility. We'll be able to stay on orbit and service different orbits for weeks, if not months, potentially years. Multiple main engine burns and a service module type flexibility. Right now, we're looking at 3 different engine configurations. The tried and true RL-10, that's been our workhorse engine for both the Delta and the upper stage and the Centaur upper stage for many decades. We're also looking at the BE-3U upper stage engine for greater than 100,000 pounds of thrust that's currently being developed, and also the X-Core engine. So this provides a long duration capability for this upper stage, and the linchpin of this technology is what we call integrated vehicle fluids. It's the key ACES enabling technology. It's a patented concept, so don't you go think about designing this on your own. We'll sell it to you for a price. But it powers subsystems with what would otherwise be considered waste propellants in the ullage gases in the tanks. So these ullage gases, hydrogen and oxygen, will power an internal combustion engine. It'll be the world's first internal combustion engine in space. It's built by Roush Industries. You might have heard of them if you're a NASCAR fan, Roush Racing. They also soup up a lot of Fords and other cars. But they're building a tiny little 6-cylinder aluminum monoblock engine that will have the capability to burn this waste gas, hydrogen and oxygen. And this hydrogen and oxygen will heat up the coolant. These gases will be circulated through a heat exchanger and warmed up by the coolant from the engine, as well as through a compressor, pump it up and be able to pressurize the tanks so we can get rid of our helium bottles. It will also power a generator that will power the stage with electricity, and we'll be able to use these hydrogen-oxygen thrusters that we're developing in conjunction with IES to burn hydrogen and oxygen gas for attitude control. So we'll get rid of all of our hydrazine systems, toxic propellants. And this is an amazing new capability in partnership with NASA through CCSC, as Phil mentioned, and our Marshall and Kennedy and Glenn and Johnson Space Center friends, partners. We've been working very closely with them to demonstrate this capability, and we're about to conduct a test down at Marshall at the end of November to demonstrate the prototype system and to be able to generate pressurization for large-scale tank, the Coyote 3 there that is down at Marshall. That Coyote 3 also demonstrated tank-to-tank no vent fill transfers, fluid transfers successfully. So what does that capability give us? It gives us the ability to do multiple engine burns, from 3 on Centaur today to unlimited. Max mission duration from about 8 hours to multiple days, if not weeks or months. Peak power to beyond what's required for the Centaur, for the ACES, goes from watts to kilowatts. Avionics, right now it's a static configuration. We can add lots of capabilities. We're building in a very modular architecture to incorporate GPS or star trackers, uplink, et cetera. RCS I mentioned. Right now it's limited by the amount of hydrazine you have on board. Right now, with ACES capability, you use the ullage gases virtually unlimited. As long as you got propellant and gases in the system, you can drive it around forever. Potential reusability with refueling and an increase in our secondary payload capability. In addition to the weight savings and the cost reduction, this is extra capability to take along for the ride. And you never know when you're going to need this extra capability. Like Lewis and Clark, it proved to be invaluable to their mission and their expedition. Other things that you can think of. We're definitely open to ideas. These capabilities are not just limited to this. There's a potential to generate power to the payloads or potentially even use leftover propellants to generate water. Once ACES is in place, this new capability enables the creation of demand. This is what has been termed previously. We didn't create this term. It's been in papers before. It's called the Cislunar econosphere. And that is the space between here and the moon, all the orbits, libration points, the LEO, GEO, GTO, and anything in between. And as I mentioned before, the flat market has kept us from growing our launch rate and our capability. Obviously, we would like to see more launches, but we're not just in it for that. We'd like to see, as the Tory's vision of Cislunar 1000 is, 1,000 men and women working and living in space within 20 years. And these boxes at the bottom kind of show the different industries that would exist in these different locations, what types of markets there are. We've done an industry survey. We're currently working with others to look at the capabilities and what it would take to get there to help sustain these industries. Once this Bigelow or Axiom space stations or others get on orbit, that capability will be there to host these industries on board. And we'll be able to deliver transportation to them between orbits and from Earth to orbit and anywhere in between. So this is what we call the creation of a cislunar transportation system. With the addition of some long duration MLI, we can keep ACES in space for as long as necessary, as long as we're able to have propellant on board. And if you're able to create an industry that is able to mine propellant from the moon or asteroids or other locations, we'd be willing to buy it. It would lower the cost of in-space transportation by an order of magnitude. And that avoids having to escape from the Earth's gravity well, which is very deep. So what you see there on the bottom right is an ACES with a landing kit to go be able to pick up propellants on the moon or deliver cargo. So our goal here is to create the space transportation superhighway. It's our intent to lower the cost, increase our capability, and allow not only to transport satellites, but goods and services and people back and forth to space. With the Human Certified Atlas Centaur as our beginning, ACES and IVF will help create this cislunar commercial market. We'll be able to pick up where NASA has pre-positioned us with the space station and other capabilities and the coming HABs and the like. We'll be able to use those capabilities as stepping stones to create this cislunar market. And part of that capability is our own Sacagawea. It's the IVF. It's our ability to bring along capability that you don't know that you might need, but if you can think of uses for it today, then we're willing to consider those. That could provide a space truck delivery to and from space, could enable science missions beyond our current lift capability. Even interstellar missions have been considered. That would go from 100 years to maybe 20 years in duration. Enable prospecting, mining, manufacturing, space solar power. You've seen a lot of that already today in today's presentations, but our goal at ULA is to create new space capabilities to enable this commercial cislunar market. Thank you very much.
Don't go away.
Oh, wait, no.
Don't go away. We have questions. We have many, many questions. I'll start off with what ought to be an easy one for you.
Yeah, be nice to me.
How do you achieve such a long record of successes, 111 flights in a decade, all successful? How do you achieve that kind of record?
That's a really good question. It wasn't always that way. There was a period where we had our failures, and we learned from our failures and that scar tissue to pay very close attention to details and not to overlook anything. I had a program manager once tell me, if the vehicle is talking to you, you better listen, because it's trying to tell you something. And that has proved to be true in many instances. And that is the way we train our engineers, and we consider it one launch at a time.
Very good. I have a little bit tougher question for you, Danger. ULA has been challenged by SpaceX in a very direct way. How do you perceive the relationship? Is it possible you could partner in the future?
I would say right now we're all partners in this space endeavor together right now. We're not mortal enemies. We're not trying to kill each other. Obviously, we're partnered with Blue Origin, who has the space launch capability right now. And we're all looking to achieve the same goal, which is to be able to enable us to live and work in space, whether it's Cislunar or Mars or anything. We're all in this together. So they have actually helped us hone our sights and reach for more affordability and while maintaining our mission success record.
We're going to have to save a lot of these questions for the break time, but let me just ask this one as we run out of time here. Torrey Bruno came from the strategic missile world, well outside the space launch business. How has his experience helped to reshape ULA?
So he brings a unique perspective. I really appreciate Torrey's initiative to create an environment at ULA that is fresh, it's innovative, and it also looks at what the customer's needs are, what the demand is calling us to create. So it's not just being able to work in an innovative environment, it's also helping change our perspective into seeing the space launch and transportation from the user's eyes.
Thank you very much,
Thank
Mike.
you, Wayne.
Thank you for being here.
By the way, Wayne helped mentor me during my career, so anything I do wrong, you can blame him.